Hi everyone, welcome to another practice problem walkthrough by physacademy.com. In this video, first, we start by converting a speed and its direction to a velocity vector. Then, we find the displacement due to this velocity over a given period. Then, we find the displacement, and by having the time it takes to go through the journey, we convert it to a velocity vector. Ultimately, we convert this velocity to speed and its direction. Let's read and analyze the problem statement together. During the middle of a family picnic, Barry Allen received a message that their friends, Bruce and Hal, needed to be saved. Barry promised his partner, Iris, he would return in exactly 5 minutes. From that picnic location, Barry runs at a speed of 600 meters per second for 2 minutes at a heading of 35 degrees north of west to save Bruce. He then changed his heading to 30 degrees west of north but slows down to 400 meters per second and runs for 1 minute to save Hal. The speed changes are essentially instantaneous and not part of solving this problem. Part A, step-by-step draw a physical representation of the displacement during Barry's entire trip. Part B, what average velocity, magnitude and direction does Barry need to return to the picnic to keep his promise to Iris? I'll read through the problem sentence by sentence for Part A, then draw the corresponding vectors. If we set the picnic location at the origin of the coordinate system, Barry first travels 35 degrees north of west for 2 minutes. Remember, 2 minutes equals 120 seconds. So, if Barry's speed is 600 meters per second due 35 north of west, then his speed using cosine and since with respect to the positive direction of the x-axis is the following value. Negative 491 meters per second along the x-axis and positive 344 meters per second along the y-axis. Now that we have Barry's velocity, we can multiply it by 120 seconds to calculate his displacement vector through the first section. B. By doing so, we get negative 59.9 kilometers along the x-axis and positive 41 kilometers along the y-axis. For the second section of Barry's trip, we go through the same process, but this time, the speed is 400 meters per second, the duration is 60 seconds, and the direction with respect to the positive x-axis, as our reference axis is 120 degrees. Therefore, Barry's velocity is negative 200 meters per second along the x-axis and positive 346 meters per second along the y-axis. By multiplying Barry's velocity by 60 seconds, we get negative 12 kilometers along the x-axis and almost positive 20 kilometers along the y-axis. Now that we have the displacement vectors for the first and second parts, we can find the total displacement vector, which is negative 71 kilometers along the x-axis and positive 62 kilometers along the y-axis. But Barry needs to travel in the opposite direction of this vector to return to the picnic location or the origin of the coordinate system. So the last part of this trip will be positive 71 kilometers along the x-axis and negative 62 kilometers along the y-axis. To calculate his velocity, we divide his displacement vector by 2 minutes or 120 seconds left out of this 5 minutes trip. Doing so, we get 591 meters per second along the x-axis and negative 517 meters per second along the y-axis. Now that we have this velocity, we can find the direction of his trip on his way back to the picnic using an inverted tangent or arctangent as shown. And also we can use the square root equation to find the magnitude of this velocity or, in short, speed. The direction with respect to the positive x-axis or east will be minus 41.174 degrees, and his speed is 785 meters per second. Thank you very much for watching this video. Please check our website, physacademy.com, or our YouTube channel for more practice problems. If you found it helpful, please consider subscribing to our channel to support our work.